better or what might not be the better material to be the striker. Okay. All right, what I'm going to show you today is a design technique and how to make either the striker or what you hang from. I want you to use one of the regular polygons, right, shapes. So I'm going to show you how to draw a regular polygon using your compass. So get those compasses out and first start by estimating what you think you want. Again, you're writing yours on paper. I can draw mine bigger because my paper's bigger. So you're going to have to draw it to scale to some degree, but estimate how big you think you want it to be. If it's 12 inches in radius, that's 24 inches and 2 feet in diameter. That's a pretty big. So get in mind how big you want your what are we going to call that? What are we going to
striker.
call this? No.
Oh, the hanger.
Hanger. Okay, the hanger thing. You know, it's very important jargon we're using. How big do you want it to be? Well, you're going to start with a circle. So draw that first.
Complicated.
Let me see if I can.
Now that since the test, now we're drawing circles.
Now I'm going to demonstrate a hexagon. How to do a hexagon. But this technique will work with whatever polygon you're wishing to use. So start with a circle. Make sure you know where your center point is before you take your little pointy thing up and lose it. Because from that center point, you're going to decide where how to draw the polygon. I'm showing a regular hexagon. How many sides are in a hexagon? This is something you just took a test on. What? 6, right? So there's 6 sides. If it's regular, what does it mean about the sides?
They're all congruent.
6 angles means if it's regular,
Equal angular and equal
lateral.
equal sides,
Oh.
right? So equal,
Got it?
right?
Yes.
Equal lateral, equal sides, equal angular, equal angles. So if you drew from this center point out those 6 legs that would go out to the 6 vertexes, right? Then each one of those are going to have a equal interior angle coming away from the center. So what you're going to do with your straight edge and your protractor, did I tell you to get those out?
Yeah.
Yes.
You're going to determine, now there are 6 of these angles, right, in a hexagon, 6 interior angles. So if you go all the way around a circle, that's 360 degrees. If they are all going to be the same, you just divide by 6 to get 60. Now if you wanted to do a pentagon, what would you divide 360 by?
5.
If you wanted to do an octagon, what would you divide 360 by? Telling you what the interior angles need to be. So you're going to use your protractor to establish a side, and then go over in my case, doing a hexagon, each of these angles will be 60 degrees. Try to be as accurate with your tools as you can be. And you're going to go all the way around the circle. Identifying the 60 degrees marks all the way around. I'll pause. Centimeters because we're proud to be Americans. If I measure that to be 28 centimeters, what part of the circle, give me the geometric phrase, what I just measured, assuming you were looking at.
You just measure.
What is that?
Radius.
That's the radius of the circle, okay? So that radius of the circle is going to be the same for each one of those marks. From those marks now, where the tick marks crossed your circle, which is what I want it to be, is the size. The radius is the size of, it's the radius of the hexagon that out to the vertexes that I've decided I wanted. I'm just going to connect Oh, and by the way, another technique hint. When you're designing things, the things, when you start making marks on your design paper, when you're at the design stage and you want to be very accurate with it, you want to draw very lightly so that things that you want to get rid of later, Cheyenne's got part of it already done. See, we're going to erase these, what we call these arcs, these circles, parts.
Oopsie. Like mine's off.
Kind of got your hexagon drawn. Is I want you to label it with what I had talked about a couple of weeks ago, design technique. Okay? So here's what I mean by that. I want to repeat some of that design technique that I had talked about before. From here to here is a certain measurement that you're going to want your reader to know the dimension of, right? The dimension of your shape that you're going to need, you also need to communicate. So with a straight edge, I want you to draw and then skip a space, make your arrowheads kind of stylish, and then write the number. I said it was 28, right? Have it kind of slanted to the right. Hexagons. Look at your picture. How do you think the radius length relates to the side length?
They should be the same, right?
In a regular hexagon, they will be. Pentagons, they won't. Octagons, they won't. But with hexagons, and that's another special thing about hexagons, is that the radius length is the same. Now watch what I'm doing here. I want you to see this technique. I'm going to draw the length of this side. This one. This is what I'm going to label to the reader. The tick mark that goes out from the edge needs to be perpendicular to that. So I'm going to draw two kind of borders for that side off there. They need to be perpendicular to the edge, those two border marks. Then I'm going to draw an arrow from that, those two border marks, leaving a gap in the middle somewhere. Again, giving my arrowheads a little style. And then that's 28 centimeters too. Now watch how I write the 28. I'm not going to write it. I'm going to write it so that whoever's reading it has it top and bottom of their paper, and they don't have to do this. I'm going to write it so that you read it top to bottom. Again, the numbers are using engineering technique. Slide it to the right just a little bit. And I'm communicating the units. Okay. Those are things that I wish to see in your designs. Engineering techniques. Make your designs, your hand-drawn designs, as professional. Okay. So that is the lesson in how to make regular polygons part of your designs. Now, this is the top